Hello बच्चों, let's read this question. Question says standard Gibbs energy of reaction at a certain temperature can be computed as del G is equals to del H minus T del S, and the change in the value of del H and del S for a reaction with temperature can be computed as follows. Del H T2 minus del H T1 is equals to del Cp T2 minus T1, and del S T2 minus del S T1 is equals to del Cp ln T2 by T1. Del G is equals to del H minus T del S by del G is equals to minus RT ln K equilibrium. Consider the following reaction. CO gaseous plus 2H2 gaseous is in equilibrium with CH3OH gaseous. Given change in enthalpy of formation for CH3OH is equals to minus 201 kilojoule per mole. Change in enthalpy of formation for CO gaseous is equals to minus 114 kilojoule per mole. Entropy for CH3OH gaseous is equals to 240 joule per Kelvin per mole, and entropy for H2 gas is equals to 29 joule per Kelvin per mole. And entropy for CO gases is equals to 198 joule per Kelvin per mole, and molar heat capacity at constant pressure for H2 is equals to 28.8 joule per Kelvin per mole, and molar heat capacity at constant pressure for carbon monoxide is equals to 29.4 joule per Kelvin per mole, and molar heat capacity at constant pressure for CH3OH is equals to 44 joule per Kelvin per mole. And ln 320 divided by 300 is equals to 0.06, all data at 300 Kelvin. We have to find out change in Gibbs free energy at 320 Kelvin is, and the values are minus 48295.2 kilojoule per mole, minus 240.85 kilojoule per mole, 240.85 kilojoule per mole, and minus 81.91 kilojoule per mole. Now we have to calculate the value of change in Gibbs free energy. So we can write our key concept. This value can be calculated as del G reaction. It is equals to del H minus T del S. ओके सो जो ये वाले डेटाज दिए हुए हैं हमें क्वेश्चन में, वो डेटा क्या दिए हुए हैं, वो सारे 300 केल्विन पे दिए हुए हैं. तो सबसे पहले हमें डेल एच और डेल एस 320 केल्विन पे निकालने पड़ेंगे, उसके बाद हम द वैल्यू इसकी निकाल सकते हैं. सो 320 केल्विन पर सबसे पहले हम निकालेंगे एंथैल्पी ऑफ रिएक्शन. सो at 320 Kelvin the enthalpy of reaction, it is equals to enthalpy of reaction at 300 Kelvin plus del R Cp naught T2 minus T1. Okay, now for this we have to calculate enthalpy of reaction at 300 Kelvin. So enthalpy of reaction at 300 Kelvin, that is enthalpy of reaction at 300 Kelvin, it is equals to summation of enthalpy of formation at product side minus summation of enthalpy of formation at reactant side. Now we can substitute the values in this. So the values are at product side CH3OH is present, and for CH3OH the value is minus 201, minus at product side here CO and H2 are present. For H2 the value is equals to 0, and for CO the value is equals to minus 114. So minus 114. So the value comes out to be here, the enthalpy of reaction at 300 Kelvin, it comes out to be minus 87 kilojoule per mole. Now we have to calculate the value of this Cp value. That means molar heat capacity, standard molar heat capacity of this reaction at constant pressure. So this is del, here we can write that, this del R Cp naught is equals to summation of Cp at product side minus summation of Cp at reactant side. Now we can substitute the values here. So at product side here CH3OH is present and the value is 44, minus at reactant side here CO and H2 are present. For CO the value is 29.4, and for H2 there are 2 H2 are present, so 2 multiplied by the value is 28.8. Now this is equals to 44 minus 29.4, here it is in plus because we are summation, we are adding this, plus here it is equals to 57.6. So 44 minus 87, this is equals to minus 43. This is in joule per Kelvin per mole. Now we can substitute the value and we can calculate the change in enthalpy of reaction at 320 Kelvin. So the value is, here we can write change in enthalpy of reaction at 320 Kelvin. It is equals to, the value at 300 Kelvin is minus 87 plus the value of Cp, it comes out to be minus 43 multiplied by T2 is 320 minus T1 is 300. So after calculation this value comes out to be minus 87 point. Here this value is given in joules. This 43 is given in joules, so that is why we will divide it by 1000, so that convert into kilojoule, because 87 is in kilojoule. Now the value comes out to be minus 87.86 in kilojoule per mole. So this is the enthalpy of reaction at 320 Kelvin. Now we have to find out entropy of reaction at 320 Kelvin. So the entropy of reaction at 320 Kelvin, it is entropy of reaction at 320 Kelvin. It can be written as entropy of reaction at 300 plus del Cp naught del R Cp naught ln T2 by T1. This is equals to molar heat standard molar heat capacity at constant pressure. Now we can substitute the values here. Firstly we have to calculate at 300 Kelvin entropy, so that this value at 300 Kelvin, it is equals to summation of entropy at product side minus summation of entropy at reactant side. At product side we have the values of CH3OH, which is given that for CH3OH the value is equals to, here it is 240. So we can write here 240 minus the value for H2 is 29 and for CO is 198. So 198 plus 29, here it is 29 or 29, yeah, 29 multiplied by 2, because 2 moles are present. So finally it comes out to be minus 16. This is equals to minus 16 joule per Kelvin per mole. Now we have this value we already calculated. Now we can calculate the value of entropy of reaction at 320 Kelvin. It is equals to minus 16. It is equals to minus 16 plus the value of Cp, it is equals to minus 43. So here it is minus 43 multiplied by ln T2 is 320 divided by T1 is 300. This ln 320 divided by 300 is given, that is equals to 0.06. So we can write here minus 16 plus minus 43 multiplied by 0.06. So the final value comes out to be minus 18.58. So this is the value of entropy of reaction at 320 Kelvin. Now we can calculate the value of del G. So del G at 320 Kelvin, it is equals to del H minus T del S. Now the datas are all at 320 Kelvin. We have the values. Now we can substitute easily. So del H is equals to minus 87.86 minus temperature is 320 multiplied by the value of del S. Del S is equals to minus 18.58. Now the value of del S is in joule per Kelvin per mole and the value of enthalpy is in kilojoule per mole. So we will convert this value by dividing in 1000. So the value comes out to be the Gibbs free energy of the reaction. Here the Gibbs free energy of the reaction, it is equals to standard value, it is equals to minus 81.91 kilojoule per mole. Now we will check the options. In the options, the option D is the correct choice for this question. Hope you understood it well. All the best and thank you.